Hello everyone, welcome to part 2 on our testing of studs and nuts here at Fanta Machine. Today we're going to be testing clamping force. Previously we did the effects of lubrication, how that affects clamping force. If you haven't seen that video, go back and watch it. It's quite informative, tells you a lot of details. We went through all these. We kind of set a baseline here by using ARP nuts, washers, lube, and the studs we make here at Fanta Machine. We check for repeatability. If you watch the numbers, they came up pretty good. We set the baseline. The one thing we did not do in that session was use our washer versus no washer. So we're going to do that right now, just to get that out of the way. Now we're using our standard 9/16 studs, nuts, all that. That's what we sell the most of here, so that's what we're testing. We want our customers to be able to see what we've got. So we're torquing these down to 180 foot-pounds of torque. This has got the cast iron washer on the inside to simulate a head or a block, the hardened washer, and the ARP nut. That snapped at about 1,000. And at about 1,000. And just short of 1,000. Now we're going to take the washer out of there, the hardened steel washer, and see what we get for a difference. So now it's just the flange nut. We use the ARP flange nuts, the 12 points, against this cast iron washer. It clicked at about 900. It clicked at 900, just a hair short. Only 800 that time. Well, looks like we're going to be using the hardened washers every time to get a more consistent read. At any rate, we're testing several different ways of clamping here. We've already done the stud, and we're getting about 1,000 pounds of force on the gauge. Now when we're all done here, we'll calculate out just how much clamping force that really is. First up, we've got a bolt that we're going to put on here. So I have the cast iron washer with the lube. We've got a washer that's been lubed. And this is screwing into a piece of cast iron that's been drilled and tapped. No, oop, wrong socket. Now the studs we were then testing have been fine thread in one end. Now we're going to check, this is a coarse thread bolt. Oof, we're going to stop there because it's giving. I could feel it yield as I was turning it. So taking any farther it would simply snap. So what we're going to check now is, we've got one here that we made that's coarse thread on both ends. I was watching some videos on YouTube, and one guy comes on there and says the reason studs work so well is you got threads on both ends, you get twice the PSI. Okay. Let's test that. So, we got about 900. And we got about 900 again. And we got just a little under 900. We'll call it 900. We got about 900 PSI on the gauge from the double coarse thread. Next up, we've got a genuine ARP stud. I don't expect any differences really because it's fine thread just like everything else and well made. Yep, 1000 psi on the gauge. Only 900 that time. That's odd, only 900. Well, the highest one was 1000, we'll call it that. Oh, I guess I mislabeled this. This one should have been 900 here. Now what we do have also is we make some here out of H13 tool steel. These are quite a bit higher strength. And they can stand up to quite a bit more torque. ARP also has some studs that are the same strength or in the same range, and they rate those at 200 foot-pounds of torque instead of 180. So just for the fun of it, we'll torque this down to 180. And it's about 1000 on the gauge, which is to be expected. It's basically the same as the rest, except it's a harder, stronger stud. Now this is 200. We're just going to see what kind of more pressure we're going to get here. Only about 1050. And about 1050, 1075. And about 1100. Now I noticed that each time I torqued that one, it went up a little bit each time, where most of the rest stayed the same or dropped as you repeatedly torqued them. We got to do that one again. Yeah, about 1100. Okay, So, what have we got here? Our testing gizmo here has got it's a hydraulic unit. It's got a square inches of 25.2. So 25.2 times 1,000 equals 25,200. £25,000 of clamping force. Now with that gauge, as you can see, is not calibrated. We're using this more as a reference. You know, each time, that way they're all in a comparison, not an absolute. And the figures come out a little bit higher than what ARP has listed on their website as far as clamping force, but it's all in the ballpark. 25.2 times 900 equals 22,680. So we've got over 2,500 pounds of clamping force difference between a standard stud and this double coarse thread. 25.2 times 1,100 is 27,720. Stop and think of it, folks. That's a lot of force. You multiply that by the number of studs or bolts holding your head down. That's a lot. Well, what have we learned here? Fine thread seems to work better. Coarse thread isn't a whole lot farther behind. I think if you aren't running a big turbocharger or naturally aspirated, you can get by with the stock head bolts in most engines. You start putting a big turbo on it, a lot of boost. If you're running a gasoline engine or alcohol or whatever, put a lot of nitrous oxide with it. Yeah, you might want something better. But studs still give the best pressure, and they're going to last longer because they're harder. Thanks for watching, folks. Make sure you watch the rest of our series of videos. Next, we're going to be checking the strength of nuts. We'll be taking some hardware store nuts, some grade 8 nuts, wheel nuts, and of course the ARP nuts. We haven't managed to strip them or break them yet, but we'll work on it. After that, we're going to break some stuff, and then we're going to do some other testing that's going to show how deep the threads have to be in the block or the head or whatever you're fastening to before it'll strip the threads. Whether it'll strip the threads or break the stud. That's a lot more interesting than you might think. So, don't skip to the end. Start at the first. They all these build on each other. So, we'll see you at the next one. Thanks for watching.